All right, I've got a quick addendum to the Module 6 lecture, and this is just based on some things that I've seen in people's work. So 3 quick things I want to touch on. 1, when you draw a curved arrow to show the movement of a pair of electrons, it should always start at a pair of electrons. And that means, in our Lewis structures, pairs of electrons are represented either as lone pairs or as bonds. So your arrow should always start at a lone pair or a bond. Now the thing is, do we draw in all the lone pairs on our skeletal structures? No, we do not. So I want you to be in the habit, when you are starting a curved arrow at a lone pair, you should draw in that particular lone pair. So for instance, if I wanted to show the resonance, say in this molecule, I see this molecule here, and I want to show the curved arrows that show the resonance. First of all, common error here is to look and say, oh, I think the resonance structure is going to have the double bond down here to the nitrogen. Right? A lot of people recognize that. Oh, I'm going to move the double bond. What do you think is the wrong way to show curved arrows moving that double bond? This is a classic error. Some of you have made it. Yep. Yeah. Moving the double bond and saying, oh, I'm just going to push the electrons that way. What's wrong with pushing the electrons that way? Well, you're taking electrons away from oxygen, which means oxygen's no longer going to have a full octet. What about nitrogen? What's not shown on nitrogen? It's got a lone pair. So, if you have nitrogen over here, if we draw in the lone pairs here, what we would end up with is nitrogen with 4 bonds and a lone pair. So that would be a Texas nitrogen. We end up with oxygen with 2 bonds and a lone pair. 2 lone pairs and a bond. That is under an octet. Both of those are things that should never, ever, ever, ever be found, right? So this has Texas nitrogen. This is under an octet. So this is bad, 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 all right? Don't do this. All right. So what should you do instead? What you want to do is recognize, well, nitrogen here is the one that has the extra pair of electrons that it should be willing to share. And I've seen some people just draw the arrow from the nitrogen, but the N itself isn't a pair of electrons. So what I want you to do is draw in the lone pair and start your arrow at the lone pair and say, okay, it's this pair of electrons that's moving, and then the pi bond is moving up onto oxygen. All right. So draw in the lone pair, and you get your alternate resonance structure like this. You don't need to draw in every lone pair on the structure. That's not necessary. But when you start an arrow at a lone pair, draw that lone pair in. All right? That's the first point I wanted to bring up. Second thing I wanted to bring up is, I didn't make this clear the first time around, but only draw one set of curved arrows on a given structure. So if I give you, say, a structure like this, and I ask you to show the arrows to get to these 2 other resonance structures. So you could draw one resonance structure like this, or you could draw another resonance structure like this. One thing I'm seeing is some people drawing both sets of arrows on the same resonance structure. Or I've seen some people like go to the second resonance structure and draw the arrows that would have gotten you there. The point of the curved arrows is to actually show how you get from your starting point to the other structure. So to go to the resonance structure on the right, I would draw this set of curved arrows. I'd draw in my lone pair on nitrogen, push them up this way. What I don't want you to see is then a second set of arrows on the same structure like this. You know, oh, now if I move this way, it'll get to the other structure. That just gets cluttered. It's not something I want you to do. So just do one at a time. Draw this purple set. That shows how you get to the resonance structure on the right. If you want to show you how you get to the resonance structure at the bottom, you have two options. You could go over to the resonance structure on the right and then draw the curved arrows to get from the structure on the right to the structure at the bottom there. That would start with what pair of electrons? Where would I start my arrow pushing to get from the structure on the right to the structure down here at the bottom left? Who's got the extra electrons? The oxygen. Yeah, so those are going to be the electrons that I want to start with. They'll push back down. Now I have to make room at this carbon. In order to make room at the carbon, I need to move this pi bond somewhere. Where's the pi bond going to go? Back over to the other carbon, other nitrogen carbon bond, and then I push electrons up there. So that would show me how I get from the second resonance structure to the third resonance structure. Another option would be draw my original structure again and just draw the arrows to get from that back to this structure. So my other option would be redraw the original structure and just draw the arrows from there to the structure at the bottom. Either one of those is acceptable, but don't draw two sets of arrows on the same structure. All right. All right, my third point I wanted to make, third quick point, the one resonance structure a lot of people are missing are resonance structures that have a lone pair on carbon. This has been kind of a common theme in what I'm seeing. Remember that when you put a lone pair on carbon, it gives carbon a negative formal charge, which isn't particularly favorable because carbon is not very electronegative. But it's still more favorable than drawing a resonance structure with a positive charge on carbon because having a positive charge on carbon, bless you, breaks the octet rule. So I've seen if you have a structure like this, most people are seeing the arrow pushing where we push the electrons from the nitrogen to there up onto the oxygen. This one most people are getting. But then what people are missing is the fact that, well, that electron pair can stop in the middle. We don't need to push it all the way up onto the oxygen. We could just push this pi bond onto the carbon. And so this is a valid resonance structure that a lot of people are missing. It's less stable than the other. It's definitely a less stable resonance structure because it puts a negative charge on carbon, but a lot of people have been missing that one even though it's a possibility. Okay? So, those are the things I wanted to point out. And that's about our time for today. Oh! And thank you for pointing out, I left out a formal charge. Oh, man. Terrible. You can tell I'm rushing.